Alright guys, so today we're just gonna talk a little bit about how important water really is, and I just want to emphasize some important points for you. So, water is used for a lot of stuff, clearly. Drinking, cooking, cleaning, washing, all of these different things. Water is never pure. Pure water, 100% pure, unadulterated H2O with no salts and no minerals whatsoever is actually very detrimental to you. You can't drink it. It typically takes 3 times to distill water before it gets to that point. No water ever sold in any stores is ever that type of water. All water, fresh water, bottled water, water running in a creek, in a lake, in a pond, all of it has a very small amount of salt. Obviously, salt water has significantly more salt, but all forms of water have a little tiny bit of salt in it. So water is actually not pure. It's not pure H2O. Here we're going to look at the lack of water access, freshwater access we actually have. If you take away technology and our ability to get water out of the ground, to manipulate it in some fashion, and you think about, if the only way to obtain water was to take a cup and stick it in a stream or something, the amount of water actually physically available to us is very, very little. When you think about the earth and you think about that the earth is covered in 70% water, almost 100% of that is salt water. And you can't drink salt water. The salt content of seawater is greater than the salt content of your cells. And so if you drink salt water, the water actually comes out of your cells through the process of osmosis, and you dehydrate yourself. If you drink salt water, you can actually kill yourself through dehydration. So you can't drink salt water. It's not accessible. It has to be manipulated in some fashion in order to be drinkable. Fresh water, however, does not need to be manipulated, but only about 2.5% of all of the water on the entire planet is actually fresh water. Now, that may come as a surprise to some people, and especially for those of us living in New York, because you can't walk a mile and not encounter some type of fresh water in our northeastern region. There's freshwater rivers, lakes, and ponds everywhere. And so to us, it seems like there's plenty of water, but really the entire world is in a water deficit, essentially a drought. Of the 2.5% of water that is fresh water on this planet, almost a whole 2% of that is held up in ice caps and glaciers. And you can't exactly just, go to a glacier and drink water from it. You got to chop it off, melt it down, and then turn it into liquid form. You'd be able to drink it. So the water held up in a glacier and ice cap, it's not accessible. It's not really available for use. Then we have groundwater, almost a whole 0.5%. Groundwater in the ground, all the way inside the earth, in the rock layers. You can't obtain that water without some type of mechanical tool, a well, a drill, something to get that water out of the ground. We do get lucky in some areas where you have springs, where water outcrops, where that rock layer crops out of the ground and you have a spring head, be it one under pressure or not, water that creeps up a fault line, a crack in the rock layers, and those kinds of things. But those are less common than you might imagine. And in terms of groundwater, there's very limited access to that groundwater without some type of drilling technology, some type of manipulation. And then we have other water. And this is water free-flowing in rivers, lakes, and streams, the type of water that you can walk up to, stick a cup in, and drink it, so long as it's not polluted, right? But it's accessible, and that's the idea I'm trying to get you to understand here. Only about a 1/100th of 1%, so in this case, 3/100ths of all of the water, not even 1% of all of the water in the class, not even 0.1% of all the water in the world, 3/100ths. Okay, that's nothing. 0.03% of all of the water in the entire planet is accessible. That's very, very little fresh water to go around. So that's one of the reasons why it is so very important. I'm just going to cruise through here because there's a couple other little things I wanted to talk about. Yes, constructing levees. So levees can fail, clearly. We saw it with Katrina and some other flooding events. But other than just failing, they actually create other dangers when you only build them in certain regions. So if you look at this picture here, this is the Mississippi River. And you can see the Mississippi River flowing this way, and all these other rivers connecting to it, the Illinois River, the Minnesota River, the Missouri River, all these other rivers that are tributaries to the whole Mississippi River. Well, if you construct a levee in this portion of the Mississippi River to prevent flooding, but you don't construct a levee further downstream from that area, then you're going to have an increased flooding potential. When rivers flood their banks, the water flows over the edge of the river, and like you can see in this picture, water flows over the edge of the river, okay, and it gets soaked up by vegetation, soils, plant roots, and all of these things along its floodplain. And so there might be an increased amount of water during the flooding event, but a significant portion of that water is being sucked up by the floodplain and is not making its way downstream. When you have a narrow channel levee system where the river is not allowed to flood its banks, it's not coming over and being soaked up by the floodplain, then all of that water, all of the extra water is flowing further downstream. So when you construct a levee upstream, but you don't construct any levees downstream, then your flooding potential is increased. And that is the scenario that has happened in many portions of the Mississippi River, which is why municipalities are being guided to construct levees in this fashion so that the river can flood its banks and the flooding risk downstream is not as severe. All right, so one last thing to talk about here is the cone of depression and saltwater intrusion. Water flowing through rocks travels very, very slowly. It's not like water you see on the Earth's surface. It's held up in the pore spaces of solid rock, and therefore it takes a long time for that water to move through the rocks. And if a well is pumping from the rock layer where the water is stored within that aquifer, if water is being pumped out faster from the well, then it's able to recharge and move to that point where the water was just extracted from. If it's being pumped out faster than it's being replenished, then you're going to have drawdown of the water table, and you're going to have drawdown that happens in this cone shape where you have less water directly from the point of where it's being removed. Okay, so you get this cone of depression, and that can alter the direction of groundwater flow, and it can also cause dry wells. For example, you have some water wells here, maybe for home use, domestic use, and then you have this really large, deep water well, most likely used for agriculture. Over time, you're going to have more water coming from the agricultural well because the farm requires more water from that well. You're going to have very little water in comparison coming out of these water wells. You can see in the second picture down here where you get this cone of depression where more water is being drawn out of the deeper well. That causes the flow of water to change and also for the wells to run dry. Now, with saltwater intrusion, it's a similar concept where you have a drawdown of the water table, but also with saltwater intrusion, you might draw in the underlying saltwater. Now, think about this. Salty water has a higher salt concentration, and therefore it's more dense. So salt water resides below fresh water. Fresh water sits on top, salt water sits on the bottom. So when you draw out the fresh water, you get closer and closer to drawing in the salt water. If you overdraw, sucking the water out faster than the water is being replenished to that point, then you can have not only drawdown in the development of a cone of depression, but as well it can result in saltwater intrusion. This is a serious problem along coastal regions.